Hi folks, I'm going to show you, I've been talking about this Apple II Plus and how hard it has been to get it working. The other day after my last video, I found another bad chip. So I figured I'd show you, even though the system's working, that it's got bad chips in it and what a bad signal looks like versus a good signal. So I put the bad chip back in, and I've got over here I've got my scope going, and I'm recording the output of that, so I'll show that in an inset. And I'll show you the difference between a good output and a bad output on one of these TTL chips. So let me flip the computer on, see if it boots up. Even though it's got a bad chip in it, it's likely to boot up. Here it goes. And it does. And this is part of what makes things so hard. I just booted the system, even though it's got a bad chip in it. So I'll take the scope. And what's wrong here is there's a... actually... I will pull out the schematic. See if you can see this. So basically, chip H12 right here is a, I believe it's a device select or IO select that basically takes 3 address bits, 8, 9, and 10, and does a decode on it and selects one of the ports. Well, it turns out the output for slot 4, which is pin 11, is bad. So I will show you some of the other pins, and I'll show you slot 4 and the difference between a good output and a bad output. So let's go to it. I've got the scope set up. All I got to do is probe it. So I'll probe a good output. And it's easier if I put a light on here because I got bad eyes. So there, let me see here. There is a good output. It's about at 4 volts. Okay, and there's a bad output. It's like 2.5 volts, and I'll show you some. That was pin 11. There's some more good outputs. So even though it's got a bad output to pin 4, and I do have a card in slot 4, which means it the TTL level is kind of marginal. The system's operating. So this is what makes debugging these Apples so hard in any system with TTL. Is actually I've got a bad chip here, and the system's still operating, and the signal level when you first look at it looks, let me put a light in here. It looks kind of okay, but if you compare it to another signal, it's not okay, because this is at 4 volts. This one's at like 2.5 volts, which is just marginal. So what's meaning is the transistor that's driving this output is not working, and it's just floating high. If you had a like a tri-state output on one of these chips, it would look about the same. So it's just floating there. So sometimes it'll work, sometimes it won't. So here you got a system that's working, but it's really broken. And I can even run. I can run this program and it actually accesses the card in slot 4, and it seems to work. So, I mean, but the problem is it's not going to be reliable. So, and you can see, you really can't see the screen here, but it's basically reading all the sensors off this card I put in slot 4. So that's what I wanted to show you. I guess I could take a minute and put a good chip in there and show you that it's not. The other thing you got to be careful of is sometimes you get a bad input and it can pull the output low. So even though the output's not going high, that doesn't necessarily mean that the output on that TTL chip is bad. It could mean there's a problem on that somewhere else on that signal that's pulling it down, and it's not allowing the output to work. And the way I can do that, actually I'll do it right now. I'll put a good chip in there and check the same signal, and you'll be able to see that it goes up to the proper voltage. So we know it's not something else on that signal chain that's causing problems. When I first discovered this problem, I pulled the card out of slot 4 because I was afraid maybe there's something wrong with the card that was in slot 4 that was causing this problem. So this chip is going in the garbage, and I'll put a good one in. I used to hang on to everything. Oops, I just put that backwards. That's not good. I did. I need light. Okay. So make sure I didn't bend over any pins. So it looks good. So I'll power this up and it boots. And I'll look at pin 11 again with my light. There's pin 9. There's pin 10. And there's pin 11. It's up all the way to 4 volts. So we know that it wasn't something else on that signal chain that was causing the output not to go high. So it's really essential to use an oscilloscope to debug these, because this signal was pretty static. It's only used to select when somebody's reading the something from that slot, accessing that slot 4. But there's other signals I've had that are like data bus or address bus signals that go like that, and they're transitioning all the time. So you can't use like a voltmeter. Hey, this thing's only at 3 volts, because the signal's transitioning all the time. Or a clock signal could be another case. If that output's bad, a voltmeter won't be any use, because that signal's constantly running, changing states. So it's really essential you use an oscilloscope to debug these things. And how I found this signal was I was just having a little bit of flaky operation, and I suspected it had something to do with the slots. So I pulled up the schematic, like I showed you, that shows where you're accessing slots. So I just probed every pin on both these H2 and H12. Because those are the 2 chips that are very specific to the slot addressing. So I looked one signal at a time down every pin on both these chips until I found the bad one. But I've had to find a number of problems on this board that way, just by scanning through the chips, looking one pin at a time, looking for bad outputs. And I found 2 or 3 maybe 3 or 4 bad chips that way. So anyway, I just wanted to share that, and have a great day. Thanks for visiting. Bye.